So today we are going to talk about assignment 3, buffer overflow. So what is buffer overflow? For example, today we have this memory layout, and if we have variable called buffer, and the buffer has a size of 24 bytes, if we put something more than 24 bytes, for example, 96 bytes, into this buffer, instead of just putting only 24 bytes into this memory, we are actually putting 96 bytes into the memory, right? So this is called buffer overflow. The data overflow from the buffer area to the nearby memory. So let's explain how does the buffer overflow attack happen. Before that, we will have to understand the memory layout. So for example, we have this function code right here. When the function is being executed, then its corresponding memory layout will look like this. There will be a previous frame pointer, or EBP, extended base pointer. The purpose of this extended base pointer, it is like a reference pointer for the system so that the system can easily find the nearby local variables and the parameters. So the local variables will be placed lower over here, below the base pointer, and the parameters will be placed over here above the base pointer. Now there is one thing I haven't mentioned yet. It's the return address. This return address is very important because it is where the buffer overflow attack takes place. Now, what is return address? The return address store the address of the next instruction. So for example, there is an address called 0xAAA. And then this return address also stores 0AAA. Then when this function is finished, then the system will come to this address, take a look into it, and see what is the address it stored. And then the system will go to that address and then start to run the instruction over here. This is how the system views the return address. Alright, so let's explain how buffer overflow attack happens. So in this scenario, we have a function, right? And inside the function, there is a buffer with size of 12 bytes. If attackers wants to use the buffer overflow attack to gain a root privilege, right? To gain the root privilege, they will have to do this. They will have to intentionally crafted a malicious data, right? Which is larger than 12 bytes, and then put all this data into this buffer over here. So let's put it into there. All right. So the attacker put all this data into the buffer, right? And then what is their intention? Their intention is to replace the address over here. They want to overwrite the address over here because they have the malicious code put into the address 0xBBB, so that they want to overwrite this address to 0xBBB, so that when the function has finished executing, then the system will come to this place, will come to the return address and take a look into it, 0xBBB. So the system will come to this address, and start to execute this malicious code. Attackers will gain the root privilege. So this is basically how the buffer overflow attack happens. Alright, so let's demonstrate how to perform the buffer overflow attack. Inside the virtual machine, you have to turn off some mitigation. The first thing you want to turn off is the address space randomization. This address space randomization will prevent us from performing the buffer overflow attack. We will have to turn it off in this assignment. So you will type this to turn it off. All right. Now, the second thing is that we will have to change our default shell. We will have to change it to Z shell. Now, at this point, I think the environment setup is done. So right now, let's create a vulnerable file called stack.c. All right, and inside this file, you'll see there is a function called BOF, and this function is vulnerable to buffer overflow attack. As you can see over here, it has a buffer, right? And it only has a size of 24. And of course, if the input is more than 24 bytes, then the buffer overflow will happen. So yeah, so this is basically it. Now, the second thing is that we will have to create a bat file. So the reason why we need the stack.c to be able to run, we want to know what is the address. What is the address of the base pointer, right? And the address of the buffer. This two address is important because we will use it later. So let's create a debug file for stack.c. Okay, and then run the debug file. Okay, so we have entered the debug mode, and let's set a breakpoint at the function BOF. So set the breakpoint at the BOF, and then we run the code. All right, so here we will want to see what is the address of the base pointer. It is 0xbFFFEB08. So let's make some note over here. How about the address of the buffer? I'll write it over here instead. Let's see what is the memory difference between them. Okay, so they have the memory difference 32, right? Okay, so this information will be useful later. So let's quit the debug mode, clear everything. Now let's create a exploit file, right? And the exploit file will help us to create this attacker file, the attacker data. Let's open up the exploit .py. So over here, you will have to type your own address, right? Buffer address and then the base pointer address. So in our example, the buffer address will be like this over here. And then the base pointer will be here, over here. Okay. And then the offset will be the address of the base pointer minus the address of the buffer plus 4. The return address will be the address of the malicious code. Okay, and how to calculate this? In this code, the entire content is 517 bytes. Now, the shell code is the malicious code over here, right? What the shell code does over here is that it will open up the shell. So 517 minus the length of the shell code is the starting point of the malicious code. This is the start. the size of the shell code is 24. The size of the shell code over here is 24. This is 24 bytes. What this line of code does is that it will put the shell code from the starting point to the end. Okay, so this line of code basically does this. So from the starting point, from this starting point, it will put the malicious code to the end, which is the shell code in our case. And then the buffer's address is over here, and the base pointer address is over here. Okay, so the offset will be like this, and the return, the offset will be the base pointer minus buffer plus 4. I will explain why we have to plus 4 over here. Okay, so the return here is we will have to calculate what is the address of the malicious code. So instead of writing return, I would prefer to change it to instead of writing return, I would prefer to change it to the address of malicious code. Okay, and this one we'll have to change it to the address of the malicious code, this one as well. Okay, so the address of the malicious code will be the base pointer plus 493. This is how the numbers come from. So the base pointer is over here, right? The base pointer is over here. The address of the malicious code is over here. So since the shell code is 24 bytes, 517 minus 24 equals to 3 equals to 493. So this is how the 493 comes from. So what this line of code does is that it will put this address of the malicious code to this position. So it will put this address, the address of the malicious code, to over here. And why is it offset? So this is the starting point of the content, right? The starting point of the entire content, and the offset is equals to here, right? The base pointer minus buffer. So the base pointer minus buffer. So this is the offset. And then plus 4. Plus 4 means that we comes to the return address. So the address of the malicious code will be written into this block, right? So like this. The address will be written in this block over here. And for the rest of the arrays, we don't care. We just put garbage inside. Yeah, so at this point, our attacker file is basically ready. So let's save this. All right, so what we want to do right now is to generate this attacker data. All right, so let's run this code. Oh, remember that in the assignment, the attacker data is also known as the bat file. Okay, so in order to generate that data, we will have python.py. Okay, so right now we have generate a new bat file. All right, the new bat file is basically this. So we have to generate this bat file. Okay. Now, the next thing we will run stack.c, the vulnerable code, and the code will read this file, the bat file, into the buffer. After reading the bat file into the buffer, the attacker will overwrite the return address to a new address. All right, the new address where it contains the malicious code. So we will run the vulnerable code stack.c. Right, we generate vulnerable execution file. And before we run that executable file, we'll have to change the file owner to the root, right? And the second is to enable the set UID. By using the set UID, when the attacker runs this file, the stack file, the attacker will run it as with the root privilege. So you will see later. And as you can see, we have successfully get the root privilege. Yeah, this is basically how you perform the buffer overflow attack. So if you have any question, feel free to email me. Bye.